Nice.
Now you can see me. Good to see you. How are you?
Good. Where are you located? In Australia?
I'm in.
UK?
No, I wish I was down in Australia. That'd be nice to have an accent
Out.
like that, wouldn't it?
Out in Australia. Out.
Out in Australia. No, I'm. Yeah, I wish outback. I'm in. Yeah, no, I'm in the UK. I'm in Cambridge.
All right.
That sort of area.
I can't tell the difference between a UK accent and an Australian accent. So sorry.
Our Australian accents are a lot more like that. A little bit more in the nasally kind of area.
Well, sounds like me.
Probably a good way to start then is if I kind of outline maybe my position on the shape of the Earth, and we can maybe go from there. As I mentioned
Sure.
in the email, I'm not really one to debate things. I'm not really interested in defending anything. I'm just looking to hear other perspectives of different subjects. So, say, my main area of interest is life after death and the nature of consciousness. So,
I like that.
I'm not unfamiliar to the fringe ideas. So it's basically my position as in terms of the shape of the Earth is, as we just mentioned, if someone were to put a gun to my head and told me what shape is the Earth, I would say it with honesty, which I think is the only real honest position for most people, is I don't know. I've never seen it. I've never been up into space to see it. But I would also say that, I've been taught from birth, really, I suppose, that the Earth is a globe, and I've as of yet seen no or not reasonable enough evidence just to make me disbelieve that.
You were
I
also
suppose it'd
taught
be
that the government is here for your benefit.
yeah.
Okay. You were also taught that becoming
Mm.
a human pincushion will save you from the boogeyman.
Mm.
Okay. You were also taught that oil was from dinosaurs.
Mm.
You were also taught 100 other things that are not true. So I'm just saying what you were taught doesn't make it true. It means that's what you
No,
were
of
taught.
course.
And the people that teach you are people that have an interest in keeping you controlled. So we'll go from there.
Well, I mean, certainly, perhaps if you look at it from that perspective, I would argue that perhaps those that taught me personally weren't of that vested interest, but you could, I suppose, argue that they have been kind of directed by those
Well,
who
let me
have
ask
the
you a
vested
question.
interest.
Did you go?
Mm.
You? I assume you went to school, graduated high
Yeah,
school, right?
yeah.
And what was your goal in high school to get through it?
To
Get a
get
good
out there as
grade,
quick as possible.
and
I
get a good
hated it.
grade so your parents wouldn't be upset and you could get out. So
Well, I mean,
how do you get an
I
A?
just wanted to.
How do you get an A in a course?
How do you get an A in a course? By learning what you need to learn to pass an exam, and then after that, it doesn't really mean much. I don't
Memorize, and
think.
regurgitate. If you even if
Mm.
it's a lie, if you could repeat what's in the book, you get an A.
Mm.
So the book written by people like the Rockefellers and others that control the education system, they are teaching you what to not how to think, but what to think, and you get an A.
Mm-hmm.
And then after 15 years of indoctrination, you get a certificate that says you are now qualified to get a loan and go into more debt to go to college. Right? That's all.
Yeah, I completely agree with that. I don't like the school system. I think it teaches you certainly how to be useful in society, the way society is, but it doesn't teach you really how to think about life, how to approach things in life. Like, as I'm sure you'd probably agree, I'm more of an advocate of don't believe what you're told until you can verify it for yourself, or at least
As
believe something without, as far as without reasonable doubt.
you sound very reasonable. Crow 777 Radio, great podcast, says belief is the enemy of knowing, right? Because it's easy to believe. I believe that you're in the UK because you told me you sound like you're in the UK. The time of this interview makes sense that you're in the UK. So I believe it. I don't know it. Maybe you're in
Mm.
Australia.
Mm.
Okay. Maybe.
Mm.
But it would take time and effort for me to know it. I would have to find you on
Mm.
Facebook. Oh, look, I took a picture yesterday. Look, the metadata. I could take the time and say, all right, now I know that you're in the UK. So
Mm.
belief is the lazy man's knowing, right? And
Mm.
belief is,
Well,
and people are lazy. So we have lots of beliefs and lots of wrong beliefs.
mhm. Well, I think that's the thing. I'd say belief is common to every man, woman, and child. We can't live life without beliefs, otherwise we wouldn't be able to be productive for ourselves or anyone else. But the difference is when you hold a belief that is not open to being wrong, that's where the problem starts, because then no matter what's right, you'll never believe it because you're so staunch in your belief that nothing can sway you.
It's easier to fool somebody than to convince them they've been fooled. Right?
Indeed,
And
the famous quote.
We have all been fooled. We've all been fooled, provably so. But it takes time and effort and sacrifice to live a truth that the majority of the other people, which is changing, by the way, believe, right? Because people want to be in social circles. They don't want to be outcasts. They don't want to be laughed at. They don't want to be ridiculed. And flat Earth used to do that. Now people are like, flat Earth. People are converting so fast right now. But it takes time and effort. And most people are like, you know what? I got my job. I get 2 weeks off, for vacation. I get weekends off. And in the summers, I get a half day on Friday. So life is good, right? That's not life. You're working, to pay for your power bill and your gas bill and your rent, right? So, you work your whole life for those things that shouldn't really cost anything. There's free energy here. There used to be free energy here available to everybody, and now we have to pay for it.
Well, I suppose contemporary life anyway, is kind of getting the best you can out of a system that's not particularly tailored for your well-being as a human being.
Right.
As a member of society, perhaps, but as a human being, certainly not, I would say. Getting
back to your previous statement, you were taught the Earth is a globe. You were taught a lot of nonsense. But so we have proofs that we can prove that it's not a globe. Now, if you ask me, Dave, how's the flat Earth made? What is it exact? I don't know. But I can prove that it's a level, non-rotating, non-moving, topographical, horizontal plane. I can prove it's not a globe of any size. I mean, it'd have to be 1,000,000 times bigger than it is for us to observe what we can observe, right? Like, for example, this ball, does it have curvature? Does this ball have curvature?
Yes. Yeah.
Of course it does. And if I take my finger and I go away, my fingernail will disappear behind the physical curvature. And zoom in, still can't see it because there's physical curvature. So with the size that they give us a radius of the Earth and the circumference, we know what that curvature formula is using the Pythagorean theorem, and we can see too far. So I'll show you an example of that, for example. Sure. And I mean, if you want to go down this, we'll take it one by one.
Sure. Yeah. I mean, that's why I invited you on to look at the kind of the evidence that flat Earth is genuine position, I suppose.
Yeah. The first thing is our eyesight has an angular resolution limit. I'm not going to do the math here, but basically the angular resolution limits of our eyes compared to the Earth curve, alleged curve, is the exact same number to like the 5th decimal point. So they hijacked our eyesight and called it Earth curve because we can't see forever. I can't see you in the UK. I'm on the shore of America. I'm on the East Coast. I can't see you because of the limits of our eyes and the light attenuation through the atmosphere. So here is, let me just show you first one. Here is, where's my symbol? All right. So if we look out here, do you see a boat on the horizon out here? Anywhere? No boat.
No.
Right.
I can't. No.
Now it's not because of curvature. It's because of the angles of our eyes. So as I zoom in, if you watch right about here, all of a sudden, as I zoom in, look, there's a boat. Now I'm not zooming over the curve. I showed you can't zoom over the curve. I can see that boat. Now look, you notice there's waves here. If my finger was a wave, I can't hide that boat unless that wave was more in the foreground, and then I could hide the whole boat. Look, it looks like it's disappearing from the bottom up. And without an understanding of how our eyes work, you'd think, oh, that went over the curve. But I just proved it didn't because I can zoom in on it.
So how far away is that?
That's a
so
great
the horizon
question.
The horizon is generally what, 3 miles?
For a 6-foot person, level? It would be 3 miles. Yeah. But with waves, it would be less than 3 miles. It has to be perfectly calm, perfectly clear, and it can't be more than 3 miles. Right? It can't be more than 3 miles. But you asked,
depending on your vantage point.
Well, six
from 6
feet. Yeah, if you sit down, it's even shorter. Okay.
Yeah.
You sit down, it's even shorter. So here is a picture of, now this is already zoomed in. If I zoomed out, you can't even see these oil rigs. So I'm zoomed on these oil rigs. And there's one rig here, one rig here. I believe this one is 6 miles away and this one's 10 miles away. The observer is 6 feet high. Do you know what the where the horizon should be for this observer? It should be under 4 miles.
Right.
It's like 3 point whatever. So we'll just say 4. I'll give the globe the benefit of the doubt. I'll just always round off in favor of the globe. So 4 miles would be here, somewhere out here. So now you could say, well, look, you're missing the bottom of it. You're missing. Yeah, there's compression.
Well, I mean, you're not really missing the bottom because the horizon is still behind that.
Look at you.
You can see it behind
Look at
that
you.
ridge.
You're making my points for me. So you can still see the surface of the water here, and beyond it. So the surface of the water is the lowest thing that you can see when looking out over the water, right? If you're looking at a boat, a sailboat, the body of the boat's higher than the water. The mass of the sail is higher than the boat, right? But the water is the lowest thing you can see. So the water should disappear first, but we can see it out here. Now, the whole idea of refracting, that it's all refracting up different, every millimeter, every inch you go out, the refraction has to be different to make it stop at eye level, right? That's kind of crazy to think that refraction doesn't pop things up lower and doesn't pop things up higher. It always pops them up to exactly eye height. Here's another example. Large bodies.
And just briefly, for people that are watching, wondering why I'm not rebuting so much, because I'm not a debater. I've never really looked into flat Earth stuff, so I'm just here to kind of learn
I'm here
to learn the evidence that whether I agree with it or not. I'm just here to learn what the position is.
Great, and I don't want you to believe anything I say. I want you to go out and verify this stuff yourself. Right?
I think that's the best way.
Can you bring me 5 gallons of water without a container?
Without a container, meaning something to carry it in. No, yeah. I'd have to do very many trips.
Many trips. Well, if you put just a little bit in your hand, that's a container.
True, that's technically a container. It's
containing the water, right? You know, a drop of water you can probably do without a container, like have it on the end of a pin or something, and maybe it'll hang there. But anything bigger than a drop of water needs containment. The water has surface tension, so a drop, which is very small. So I say anything bigger than a gallon of water needs containment. So a lake needs containment, the water needs to be contained. What's it contained by? The land, which is higher than the water.
Land, yeah.
Yeah. So here's a canal or a lake, whatever you want to call it, and it's contained. And when water is at rest, it lies flat. And when it gets cold, it freezes flat. So we're on the lake now. There's ice right here. In the full video, we verify that we're on the ice and everything. 6 inches away, 6 inches high, the horizon should be like 0.88 miles away, less than a mile away, right? So they put these 4 lights on here at 8 miles, 7 miles, 6 miles, and 5 miles. Now, someone new to the topic would say, well, that's not very far. The Earth is so big. We don't know. Well, according to the radius given to us by NASA, by our science, right? And they always claim refraction, right? So they claim like 10% or 5% refraction, added 50% refraction here, which is ridiculous, right? So this light should be with a stupid amount of refraction. By the way, it's nighttime, it's cold, there's no humidity, there should be no refraction, right? But I'll point out how ridiculous refraction is. This should be 30 feet below a physical curve, 22 feet, 15 feet, and 9 feet at those distances from that elevation height. So we have 2 options. The camera's on the ice. It's like red light, blue light, orange light, yellow light. It's just there across the flat ice. Right. Or B, the camera is here 6 inches off. Here's the horizon, 0.88 miles away. And then these lights know how far it is from the camera, and so they're refracting up all those different amounts to stop perfectly on the tangent of where this camera sees it. It's not, some of them aren't popping up higher or lower. They all just magically stop on this tangent line of the camera. Which one of those is insanity? Because let me add this before you answer that. If you were never taught anything about the Earth your entire life, you would never come to the conclusion that we're a spinning, wobbling ball vortexing through an incredible, expanding universe. You would never, ever come up with that unless it was pounded into your head as a child, right? We're spinning at 1,000 miles an hour. We're orbiting at 66,600 miles an hour, and we're chasing the sun at 500,000 miles an hour. This entire system is moving sideways at millions of miles per hour, but the stars never change. I want you to go out tonight, take a picture of the stars, put a note in your calendar to take that same picture next year and in 10 years. And every star will be in the exact same position, even though we travel 4.5 billion miles a year, never to return to where we were before. And all the stars are exactly the same. Something's going on.
Sure. Okay. So, well, to answer your first question, if I suppose we in general were never taught about the globe model, then of course, yeah, the instinct would say that we were on a flat plane because our everyday life would dictate that. There'd be no reason, assuming there was no kind of aircraft or anything like that. I think it's just such a, and again, this is kind of my first proper look into the flat Earth kind of hypothesis. And I suppose it's still a very big leap for me to say that there's validity to it, I suppose. I mean, I suppose as it would for anybody that's first getting into this. But so I have a video that I took. We'll start here. I have a video that I took a couple years ago. I think it was 2023, 2022, something like that. And it was similar to yours of a ship on the horizon. And I was showing my mum, because my mum's not particularly kind of science literate. I don't want to sound cruel, but she's not particularly science literate. And I thought it'd be quite interesting for her to see kind of the concept of disappearing over the horizon. So I had my this camera that I've got up here, Sony XR53, whatever it is, and I put it down at sea level on the floor and zoomed into this ship, and you could see the poles, the rigging, whatever it was, sticking out the top, but nothing else. I then stood up, lifted it above my head, and flipped the screen down so that we could see, and you could see an awful lot more of the hull and everything, the deck and everything below it. So for me, that was kind of seeing the ship going bottom first over the horizon as one would expect. So what would be and I've got the video actually I could show you, but what would be the flat Earth model explanation for that kind of observation?
Yeah, very, very easy once you understand what's going on. It has to do with the angular resolution. The farther things go away, I'm looking for, here it is. So I have on my floor here, I have these pens. Mm-hmm. They're all a foot apart. Mm-hmm. Now you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's like 30 of them, and they go all the way here. A little hard to see, right? Mm-hmm. So I'm up high, and now I'm going to bring it down, and I want you to watch what happens. This is how our eyes work. So I want you to watch what's happening with all of these back here. They're all getting compressed together, and we're losing visual information. Keep watching. Keep watching. They're all compressing into one line, right? Mm-hmm. And now if we look at where we are, so 1, 2, I'll even go 3 to the white one, is more than half of the next 25 as far as our visual space. So if I had a little boat out there and I'm pulling it towards me at 10 seconds per pencil length, it would take forever before I'd really start it moving. It would take, 230 seconds or whatever before I'd really see it start moving. And so all of this visual space out here is compressing what I see. Any little wave, and also even if there's no waves, the atmosphere gets thicker and thicker and thicker. And then over the water, we have what's called the marine layer. It's the last couple of feet. It's really thick. And that air becomes opaque over distance. So it becomes opaque out here. And the ship just literally goes into that, and it blocks the bottom of the ship, and it blocks the whole ship. So again, I showed you the video of the oil rigs, and we can see beyond the physical limitations of the Earth. Things do disappear from the bottom up because of our angular limits. We have here in the Home Depot, I don't know what you have there, whatever big, gigantic stores you have, that have these huge warehouses. Go one end of there and put your camera down so the camera lens is closest to the floor, and look down the long aisle, and you won't be able to see that far. You won't be able to make out anything on the floor. People's feet will be missing at the other end. Okay. And then lift the camera up a little bit, and all of a sudden you'll be able to see them. That has to do with the angle of attack of your vision, seeing things. Let me show you this. All right. So here is, all right. So you agree, if we're on a ball, your point of view, you're always on top of the ball because you're standing straight up. So you're wherever you are, you're on the top of the ball.
Yeah,
right?
Relative to, yeah.
And everything you see should go down and away. The farther out you look, the farther down it should be. Not to scale. You can't see this far, but the earth is curving down and away from you in all directions.
Yeah.
Okay. All right. So let me ask you this. Is this water, this is the horizon out here. Is this water flat, or is it curving down and away?
Well, I'd say it's level.
It's level. Level, does that mean it's flat, or is it curving?
Well, I would say level is relative to the center of the Earth.
So you're saying level is curved.
Yeah.
Okay. So this water is curving.
I mean, just to add, from a human point of view, no matter where you are on the planet, it will look flat. Just as you know, for
a microbe on a basketball will see the basketball is flat. That doesn't mean that the Earth is a basketball or flat or either. It just means at certain scale you can't see, but the water should be going down and away. It should be going down and away. So if we add some boats on here, we got a boat in the foreground and a boat in the distance. Why is the bottom of this boat higher than this boat, where the boat touches the water? Why is it higher if the Earth is going down and away?
Well, I would say it's relative to the angle that you're looking at it over this relatively short distance where it appears, the ocean appears to be flat. So
whether your eye is an inch above the water, or 6 feet, or 10 feet, or 50 feet above the water directly below you would be that distance away. And the farther out you go, the water would start dropping off exponentially. It wouldn't rise up. But what's coincidental here is if we compare this to a hallway, now we know a hallway is flat, and we overlay the hallway on here, watch what happens. This is a flat hallway. Would you agree with that?
Yeah.
Always flat, right? Right.
Yeah.
And it's hard to see the doors on here, but if I overlay it on the water, it's the exact same perspective. The hallway's flat, but the water's curving, but the horizon's at the same spot. And if I add the boats in again on the curved water, and I take away the water, they're just sitting on the hallway. They match the hallway. So the hallway's flat and the water's curving. Right?
Okay, so let's
go ahead. There's a little more to go, but go ahead.
Sure. I was just going to say, if we were to take for granted that the Earth is a giant spinning ball, let's assume for argument's sake that it is, and that hallway stretches all the way around this Earth, and the Earth is so large that we can't see the curvature from our perspective because we can't see it as it goes over the horizon. You would surely, from our perspective where we are on this tiny little section of the curve, we would see the same thing, whether it was
so your
infinitely flat or...
Yeah, your answer is that the Earth is so big that flat and curved look the same from the scale that we can see. That's why
have the same kind of optic properties.
Yeah, well, that's cool, but as I showed you with the oil rigs, the radius is wrong. The Earth could still be curved, but it would have to be 1,000 times bigger than they say for us to be able to see the water beyond that oil rig. And actually, even at 1,000 times bigger, we shouldn't be able to see the water at that distance, right? So I overlaid a sunset on here. Now, when you watch, I'm going to stop it for a second. When you watch the sun appear on the horizon, it doesn't curve over your head. If you track it, it does a straight line up to its highest point and a straight line down. And this is the sun going away. And it happens to follow the exact same perspective of the hallway, and it goes into the atmos. We don't see it go behind a curve. And I could show you the sun disappearing above the horizon, right? It's just going away, following the exact same perspective. Now, this thickness right here This is that marine
Mhm.
layer I was talking about. It becomes opaque, so opaque that the sunlight can't even go through it, right? And then if I compare this to streetlights, we know that streetlights on a straight
Mhm.
street, they're all at the same height, but they appear
Yeah,
to be
they
going down. You
converge.
know
Yeah.
that this light is the same height as this light. But
Mhm.
if we overlay it onto here, again, it's the exact same line. Again, everything that we can prove is straight matches what you assume is curved.
But equally, I could say that everything that we see as a huge curve is equal to what you see with a flat model.
What? No,
But
no, no,
also,
no,
I
no, no,
just
no, 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 no. Those lights are straight and level. You admitted it. It's easy provable. The hallway is
well,
straight and
yeah.
level. But the perspective on both matches the perspective on water. It matches the
Mhm.
perspective of our sky, right? And the sun goes beyond the horizon. Boats go into the horizon. Celestial objects go beyond the horizon. So, what is the horizon? Is the question, right?
Well, I would say it's as far as you can see in any direction,
Yeah.
where
So,
the sky allegedly meets the ocean from our. But can I just quickly just
yeah,
mention
please,
one
please.
thing that I've found interesting? Could you just briefly play the sun clip again?
On this video,
Yeah,
um,
because we have a little holiday place down at the south of England where there's a really amazing sunsets, and the sun gets bigger the closer it gets to the horizon. It doesn't get smaller.
yeah, it does sometimes. So,
So, yeah, but sometimes it doesn't.
yeah, sometimes it
I
doesn't.
mean,
Right.
so how can it if it's going away,
Yeah.
which
Should get
so this is
smaller.
like it should get smaller all the time.
Are you sure?
And
Are you sure of that?
well, shouldn't it?
Well, does it? I mean, does it?
Well, I mean, I've seen. Well, I won't bring up the picture now, but I've got pictures where you can see kind of. Well, this is your camera. I've got two cameras. So there's the horizon, and sometimes the sun is say up. Oh, is this going to be difficult with this camera?
No,
But
it's all right.
sometimes the sun is up here at this sort of size when it's kind of directly above you, and it's too bright to stare at, or you'll burn your retinas off. But then when it gets down to the horizon, it's kind of like this. Probably not exactly to scale, but it's bigger and it's kind of half
And
missing,
the bottom half
and
is
it's red.
missing. Yeah,
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 and bigger than it is up here. Which
yeah. So we're gonna stick on this topic for a little bit because there's a lot I'd like to show you on this. Um, so trying to show you. All right, so here's a the sun. Oops, that.
Mhm.
Hold on a second. There it goes. All right. So this is the sun just going away, right? And it doesn't seem to be getting much smaller, but maybe it is, maybe it's not. We'll get into that. And it's going to go behind here. What is this? Now, these are mountains in Pennsylvania from Connecticut, but there's also an atmospheric opacity that it's just going beyond. It's going
Sure.
beyond it, and it disappears. It disappears like that, right? So that didn't answer your question about the size. So let me show you that. Um, here is I just got to get to it. Oh yeah. Here's the sun. Why is that doing that? Hold on.
Technology is a wonderful thing until it doesn't work, isn't
Yeah, no, it works fine. It's just me.
it?
It's just me.
Well, we're a technology.
Yeah, yeah. So here's the sun, time lapse of the sun going away. It was going down, 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 down. It kind of just
Mm.
stopped here. And now it's getting weaker and weaker as it's getting farther and farther away. And then remember, this is the horizon that you believe is Earth curve, but the sun's going to disappear above it. It's just going away into the atmos, and then it just disappears into a small dot. Right?
If you pause it there,
Yeah.
is that not going down behind thick cloud?
That's what it looks like, right? It's going beyond the clouds. The clouds are above your eye level. So here's the clouds and here's
Yeah,
the sun. And as the sun goes
yeah.
away, it looks like it's going down, but it's just going
Yeah.
beyond. And those clouds look like I have some new visuals to show that you're going to like. Um, the clouds will hide that, and even without clouds, the atmosphere um, will hide it. Let me just show you a little perspective here. So, is this line sloping down or is it level?
I would say it's sloping down.
Okay. So, is this line level or is it sloping down?
I would say yes, that's level.
It is okay. This line is level. This is the same line, just a different.
Mm-hmm.
This is a celestial
Yeah.
view, and this is a terrestrial view. And as I move it away, it's going to go beyond these mountains or cloud deck. It's just going beyond it, right? It's going beyond it, and it looks like it's going down. It's just this light moving across, never going below here. It's hard to see. That is the thing that it's going beyond. So this is the real sunset. What's it going beyond? Now, if I zoomed out, this line where the sun is setting and the line where you see the water, you can't even see the difference. And it looks like it's disappearing from the bottom up. It is. And you can't see the difference between where that line is and this line is. We zoom in on it, you can't see the difference. This line is level. This is how terrestrial perspective works, right? And then as far as the sun's size at sunset is it's all there's several things going on. First, there's atmospheric magnification, and there's which happens sometimes, so the atmosphere looks bigger. And there's also the way our brain sees. Okay, we see things near the horizon in the sky bigger. You ever see a giant full moon on the horizon?
Yeah,
Picture of it,
the giant pink ones. Yeah,
yeah, but you take a picture of it, and it's a tiny dot. You're like, no one's going to be impressed by this. Right?
Yeah, although
so let me
camera optics.
No, it's not.
No.
It's the way your brain sees it. Ready? It's gonna sound a little gay. Turn around, spread your legs, bend over, and look at the moon upside down through your legs without any optics, and the moon will look tiny.
I'll have to try it.
You short circuit the way your brain is interpreting the sky. So
although can't one argue that you can then take a perspective of the size of the moon relative to, say, the top of the trees, and you can see the comparison in real time between the size of the moon and the top of the trees compared to how it is.
I have a picture of my wife holding the sun in her hands. She's tiny, and the sun fits in her hands perfectly. What's this going behind? What's going on here? Is that the horizon of the Earth? Where's the sun going?
I can't see. It would look at first glance like it's sinking into the whatever layer that is.
But how could that be? The sun's higher.
I don't know. I'm not.
That's a good answer.
It's a meteorologist.
It's a good answer. So let's just so let me just show you. This is worth staying on for a minute. Okay, a couple minutes.
Sure.
You okay with that?
Sure.
All right. So here is, oops, that's not what I wanted. My where is my I have one second. All right, here we go. Got it. Found it. So this is a perspective grid. This is how we see the top ramps down, sides ramp in, bottom ramps up. And so here we are. So I'll put my guy here. This is his eye line here. And I'll throw this mountain in here. Let's just say it's 3,000 feet above him. Okay?
Sure.
So the mountain's 3,000 feet above him. He's standing right next to it. The sun is above the mountain. And the sun is just going to move away. Now, is the sun below the horizon or just beyond the mountain?
Just beyond the mountain.
Of course. So if he went up in the air, he could see over the mountain and see the sun again.
Yeah.
Or if he went backwards, he'll change his angle to the sun and he'll be able to see it. So we move him 25 miles away, and now that's what he sees. So his twin is 25 miles behind him, and he sees the mountain here and the sun up there because he has a better view. This guy, the other guy, is standing at the base of this mountain, and he can't see the sun because it's beyond the mountain. Right?
Again, probably not to scale, but yeah.
Not to scale, but this is absolutely super easy. So the top of this mountain is 3,000 feet over his head. Even if the Earth was a globe at 20 miles, you can take, 3,000 feet above his head. You could take, I don't know, 50 feet off, whatever. But the mountain is still well above his eye line, but he sees it and perceives it as the horizon of the earth.
Sure. Yeah,
Okay.
because at that distance, you wouldn't be able to tell the difference between
right. The height and everything compresses into the horizontal eye zone or horizon, right? The horizontal eye zone. So if the sun goes farther away, is it below the earth curve or is it beyond the mountain?
I mean, at that point, I would say, if you want me to be honest, I would say probably behind the curve at that point.
Well,
looking at based on that image, looking at the compression of that image.
He's looking up at the mountain. So that line of view is really going up, but he perceives it as level. So if he went up in the air, he would see it again. I actually have footage. Hopefully I can find it, where it sets, just like you say. And I set my drone up and there was the sun again. I'm going to show it to you in a minute. so hold on.
Let me just get that concept right. So you saw the sun from your eye level.
Yep.
Lower over the curve. Yep. And then you put your drone up how high?
Not very high at all.
Roughly, not very high, but high enough. And
couple hundred feet. I'm not seeing over the ball. I'm seeing the sun, and the sun will set above the horizon at that point because it's going into the atmos. So we got the mountain 3,000 feet above his eye line. Looks like it's at his eye line, and we have the clouds. Now the clouds are, I don't know, 5,000 feet over the mountain. The sun is higher than the clouds, so all the clouds merge into this horizontal eye zone, and the sun goes away. Did it go below the earth curve or beyond this line? It's beyond the line. Again, you think it's the earth curve, but
practically, yeah, it's beyond the line. It's beyond the line. Yeah.
So this line now is not only 3,000 feet high; it's 5,000 feet above that. So there's 8,000 feet, a minimum of 8,000 feet above his eyes, and the sun just went beyond it. It just went beyond it. If we went up,
run those numbers by me again.
So the mountain is 3,000 feet high. These clouds, let's say they're 8,000 feet up, whatever. Okay, 5,000 feet over the mountain.
Yeah.
So these clouds are also merging into this line. So this line now
is made
of opaque atmosphere that looks like it's at his eye level, but it's really
it comprises 8,000 feet.
It's 8,000 feet. And now when something goes beyond 8,000 feet, it's going to just go away. It's just going to be beyond it. So let me get my so here's an example. We got a camera on a table. Rid of that. And it's just taking this coin away. Now we're slightly below the table. Makes sense why it's disappearing from the bottom up. Right? Well, I just proved that this line is not at your eye level. It's thousands of feet above your eye level. And this is what you're seeing. The half sun just disappearing beyond something that's above your viewing level. But it appears, due to perspective, to be at your viewing level. Right?
So how would that compute to sunsets over the ocean horizon, which is flat?
Well, that's
our eye level.
I think. All right. So, whoops. All right. So,
because again, if I could just kind of briefly expand on my thoughts in that regard, because I'm thinking if it's a flat plane kind of that stretches out as far as our vision can see, it would get smaller and smaller and smaller and smaller and smaller until it just disappears into obscurity.
I can show you. After I show you this, I'll show you a dozen videos of the sun getting smaller and smaller and smaller and disappearing into obscurity of the horizon.
But that's difficult for me because I've seen it where it doesn't do that.
And as we explained before, sometimes it does, sometimes it doesn't, depending on the atmosphere and how far you're actually seeing. That horizon could be 10 miles away. It could be 50 miles away. It could be 150 miles away, right? Depending on what's going on. Are there mountains in the distance that you can't see because the light bouncing off the mountain isn't making it to you? I'll show you that also, right? So again, it's easier to believe that the sun's going behind Earth curve because you don't have to think anything beyond that. But I'm teaching you that there are better and clearer explanations that don't defy the physics of a ball 24,901 miles around. How high is this cloud? Can we say 8,000 feet?
About that, cumulus clouds, yeah.
Yeah, okay. How high is this cloud?
Probably about the same.
Yeah, and the ones in the distance here? Same.
Yeah, probably about the same.
But
Yeah.
eventually, if we doubled this distance to this cloud, it's going to be it's merged into this black line, right?
Yeah. Yeah.
Okay. So when I look up, I see blue sky because I'm not looking through. I'm just having a clear view. As the light attenuates, as I look down lower and lower, I'm looking through more and more and more atmosphere, and the colors, I see the red sky because the light is being absorbed by the atmosphere. Blue sky here, but somebody over here on this, where this horizon, apparent horizon is, they look up and see blue sky. They don't see red sky, right? They see blue sky, right? So this is the light attenuation. So you got a cloud here, got a cloud above me, and this cloud goes into the distance. I'm losing the angular resolution. This cloud is probably just as wide as this cloud, but because of my angle view, it gets tighter. And if I add another cloud here, right, it's getting harder and harder to see the bottom of that cloud. And I add one more. I just added one on the horizon. You can't even see it. It's literally become horizon, and it's black. It just becomes the horizon, right? So, and even without clouds, the atmosphere is doing that. I'm just using clouds to show you, but the atmosphere literally will compress into an opaque line that we call the horizon, or the horizontal eye zone, not the curve eye zone, the horizon. So the sun's above the clouds, and as the sun moves away, it's going to set from the bottom up beyond this cloud. Look, it's disappearing from the bottom up. Now, is there any difference between that cloud and this cloud? No, it's going to disappear from the bottom up. But I'm going to be able to see it again because this cloud's giving me some blue sky space. But then this one, it's going to disappear from the bottom up. But this one, I can't see anymore because it's merged into the horizon, and it's just going to go beyond the horizon, right? So here is, again, I'm just showing you more clouds merging into this horizontal eye zone, right? They're just getting merged. Now, this is a tree line. I'm on the water, so these trees are higher than the water. But if I double the distance to those trees, I won't see the trees. They're still above the water, and they just merge into a horizon, right? These clouds are going to merge into the horizon, and the sun will just go beyond them, right? See these clouds here? They're merging in these real life photos. And as the sun goes away, it's just going to go beyond these trees, beyond those clouds, and it's going to disappear from the bottom up. Just like you showed me that, this thing, the sun going down, right? That's what's going on. Look, the sun disappeared from the bottom up here, and it'll pop out here, and then it'll disappear beyond these trees. Beyond those trees. So here's the one I wanted to show you. So here I am. Now, these trees are obviously higher than the water, right? But this is just like 5 miles away. But to the left, I can see 20 miles away, the shoreline, and I can't even see the trees. They literally become the horizon, but they're still above the water, right? So now I send my drone up. This is 10 minutes after the sunset, and there's the sun again. And it's just sitting there. Now, I saw it go down, 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 down at a good clip, and then it just stopped, and it's not going any lower. I'm going to zoom in, and look, what is this? It's just literally disappearing. Now, everyone on the water saw the sunset from the bottom up 10 minutes ago. I'm still looking at it, just a couple 100 feet in the air, so I can see over. It's a super clear day, and it's just disappearing. These are mountains in Pennsylvania, hundreds of miles from me. And the sun is just going beyond the atmos. That's all it is.
So, okay. Yeah, I mean, it's certainly interesting. I can't really give an opinion because I'm not a meteorologist. I don't know this stuff.
Well, you don't. Here's the thing: a meteorologist is indoctrinated into believing what he believes. You're a man with God-given common sense, right? God-given common sense. You're told that this is the horizon of the Earth, and the sun should. Wait a minute, the sun's coming from above it. How come it didn't come from below it? And by the way, the sun is mirrored. The horizon's really here. Okay. The Atmos horizon's really here. And the sun is just literally coming from beyond this atmospheric deck, which is thousands and thousands of feet above your head. If you're sitting in your yard and there's a fence on the other side of your yard, 5 feet tall, and your neighbor comes, he's talking to you. When he walks away, he's going to disappear from the bottom up. The fence is going to look like it's at your eye level, but he's going to disappear from the bottom up. Does that mean his yard is curved, or is he just walking away from the fence? It just appears above the horizon, right? Now,
Yeah,
let
I
me
mean,
show you
I don't
why.
know.
Why?
Hmm.
Well, I don't know is okay, but you have the ability to learn. Now, why is this train getting smaller?
Because it's getting further away, so it appears to be getting
Perspective.
smaller.
But you
Hmm.
expect the sun to do that, right? You can say yes.
Yeah, well, you
I
would
guess
do,
so.
yeah.
Yeah, well, no, you expect it. Don't say it. I'm going to teach you something. So the train gets smaller because we are at the same level of the train. I forget the
Hmm.
principle. I think is it the Bernays principle. So this is a wall. All these lines are parallel. Even
Hmm.
these lines here, these lines are
Hmm.
parallel with this line. But this is how we see. So perspective makes things appear to go down. So here's
Appear to converge, yeah.
a side view of this guy, right? Right? No one
Hmm.
ever sees an orthographic side view in reality. So when the sun goes away, you'll see the sun will appear to go down from this guy's point of view. But this is a side view of what's actually going on. And then the sun will just disappear, as I showed you, beyond the horizon. Now, here's the train car, and the train car gets smaller because it's getting higher and farther away. When something's already farther away, it's already smaller. And as it
Hmm.
goes away, it doesn't get much smaller. And as it goes down, it's getting into thicker and thicker and thicker atmosphere. It might start expanding just due to magnification. So here I have two wiffle balls, one right here, one 6 feet away. This one is smaller than this one. So if this was the sun and it's going away, it should get smaller, right? Makes sense.
In
But
theory, yeah.
in theory, well, in what you were saying, making you believe we live on a globe. So when I lift up the camera here, I'm not going to get any closer to that ball. I'm just going to go up. So this ball
Hmm.
has some distance. And as I go up, come on. So when I go up, this ball is going to get smaller. I'm not getting any closer to this ball. And when I get up, they both appear about the same size. A little different, and sometimes we see the sun different. Sometimes we don't. But here they are. They're about the same size. And now if we're down here looking at the farther sun, all that atmos, all the water in the atmos will appear to magnify the sun. Maybe it magnifies it in a perfect yin yang, like, hey, it didn't change size. But in reality, in your globe model, in your globe model, when the sun is going around, we're spinning, but I'm just going to go, the sun's
Hmm.
coming around and it's just going around the earth like this, right? It's going around the earth like that. From
Well, yeah.
noon to sunset, how much farther from you is the sun in percentage? It's 93 million miles away. It's just
Hmm.
maybe 2 or 3 or 4,000 miles farther away. So the 0.0001% smaller, or whatever it is. It's something stupid, right? So in the heliocentric model, it should not shrink. So we had we used a solar filter, 1 million solar filter,
Right.
and we filmed the sun going away. The problem is the real part that you want to see. The solar filter when the sun is really near the horizon, that's when you get the most information. The solar filter makes it so you can't even see the sun, right? But this got 23% smaller. There's no point in the heliocentric model that the sun should get 23% smaller, right? This is another one. We filmed it, and as it's going away, its light is attenuating, and it's getting smaller. And when
This
we
is as it's setting.
yeah, as it's setting, I think someone got it. It might have been more than 23. I'll just go with the 23. It's smaller. And in the globe model, there's no explanation for that whatsoever. There's no explanation for that at all.
Mm.
Um,
I would, if I was to guess, and as I say, I'm not an expert in any of this sort of stuff, but if I was to guess, I would say on a globe model, as the Earth is set, as the sun's setting over the curve, assuming there is a curve on a globe model, otherwise it wouldn't be a globe model. It's the angle of the light is having to come through a lot more atmosphere rather than kind of more direct down. So I would probably guess definitely that there's some kind of optic light tricks going on, but I couldn't
so
say that
the
with any
globe
conviction.
model requires optic light tricks. Okay. So Here's a mountain.
Hmm.
Here's the globe, right? I bring
Hmm.
this over the mountain. The mountain's behind the curve, right?
Hmm.
So you don't have to believe anything. You can go verify this, but this is a spot in Aluja, France, and we're looking out over the ocean. From this spot, Mount Canigou is 175 miles away. And using the globe Earth calculator, the top of the tallest part of Mount Canigou should be over a half a mile below the curve, just like I brought that bottle below the curve, right? So the sun
Sure.
migrates between the Tropic of Cancer to the Tropic of Capricorn every 6 months, 6 months in, 6 months out. And twice a year, the sun will line up with this viewing spot in Mount Canigou. Now, do you see me right now?
Yes.
If I turned off every light in this room, could you see me?
Probably not.
So you're seeing the light that's bouncing off of me.
Yeah.
Okay. The light that is hitting me, the source of that light is brighter than the light that's bouncing off of me.
Sure.
A brighter light can push farther through the atmosphere.
Hmm.
Okay. Easy. That's true on flat or globe. So Mount Canigou is 175 miles out here. It's in the light, but the light that's bouncing off of Mount Canigou either can't push through the atmosphere or it's behind the physical curve.
Say that again. Sorry.
The light that's bouncing off of Mount Canigou,
Yeah.
either the earth is flat and the sun and the light can't push through 175 miles of soupy atmosphere,
Of atmosphere.
or
Right.
it's blocked by the curve.
Sure.
Okay. So on
Or
your,
a mixture of both, perhaps.
well, if it's blocked by the curve, doesn't matter how bright it is or not.
Well, when you start to invoke refraction and things like that. But yeah,
So
fair enough. Yeah.
refraction. So refraction compresses things, warps things, mirages things. It does all sorts of things. But one thing refraction doesn't do is make things that are physically blocked appear above that physical blocking. If we're on a big field and we're 10 feet apart and we're looking at each other, no problem. If I put a 10-foot wall, brick wall in between us, you can't see me. So we both started walking backwards. How far would we have to go? And what type of weather front would need to come in before I can see you above that wall?
I have no idea.
Well, you have no idea. It's not because you're stupid. It's because it's stupid, right? You would never see me again.
Well, but true, but I couldn't infer that because I don't understand it, it's that it can't be true. I might just not understand it.
I understand. Nobody has ever been able to show significantly a clear object behind a physical obstruction refract up. Yes, things can get compressed. I was looking at my wife and daughter down the beach about a mile away, and I was zooming in on them, and they literally looked like genies. They were like, their body, just
Yes,
because of the
yeah.
atmos, right? So
Mhm.
as this sun goes away, it backlights the mountain, and the top of this mountain should be a half a mile below the curve. Let me tell you your steel man for this, your argument on the globe side. The mountain is below the curve. The sun is already set, but the sun is refracting up and the mountain is refracting up, which has no light on it. So a non-lit refracting, wait a minute, you need light to refract. It refracts up and blocks the sun. That's the globe
That
answer.
seems far-fetched.
It is completely far-fetched. Here's the flat earth answer. Here's the mountain. It's right there. Across the flat plane.
Or you could posit on a globe model, you could posit that simply the dimensions of the video aren't correct.
Okay, but if you go verify them, then what? Because they have been
Well,
verified.
if you go and verify them, then that'd be very interesting.
Okay, look up Mount Canigou, do some research on it. Let me show you this one. It's just a little hard to see, and you can just look up this photo. So this is a world record photo, 275 miles. And we can see these mountains back here, and they're the right mountains, they're the right shape and everything. So 275 miles. The top of the mountain is 12,687 feet. Now we're on a mountain here. I'm not sure exactly where they are, so we put them on the highest point on the mountain, 9,272 feet. Okay, so and the higher you are, the farther you can see on a flat Earth and a globe Earth, right? So at 9,272 feet, there should be the target hidden height at 275 miles should be 16,446 feet when the mountain itself is only 12,000, but we can see almost the entire mountain over here, right? We can
So the
see the entire
concept
mountain.
being that the mountain should be 4,000 feet out of view,
The top of the mountain
the top of
should
the
be
mountain.
4,000 feet below the curve, and the rest of the mountain should be even farther, but we can see almost the entire mountain. Now, you can say refraction, magic, it's doing all of these things, all these mountains at different distances are all refracting up, appearing on a straight line, or mountains across the flat earth.
Well, from an initial look, I would say mountains, water, clouds.
What?
They look like clouds to me.
Well, they do, but you go look up this picture. These are verified, the actual mountains in the proper positions and
Right.
proper shapes.
Okay, so I see. So
yeah, you can
so
go,
you've got
nah,
mountains, water, land, water, mountains.
sure.
Okay,
The mountains stick up, they're higher than the land. Again, remember,
sure.
everything gets compressed, top down, bottom up, sides in, and back to front. It all gets compressed. It all gets compressed.
Mm-hmm.
When you're looking
Sure.
at
So,
180
yeah, I
miles,
know
when
what
you're
you mean.
looking at,
Mm-hmm.
let's say a rocket is launching 180 miles away from you, right? And
Mm-hmm.
you're looking, and the rocket launched, with the second hand point on the top of the hour, right? And you don't see the rocket appear for a minute. You can say, oh, it's coming up from behind the curve of the Earth. Or at 180 miles, how much compression is that? At 30 miles, 40 miles away, the cloud deck is completely in the horizon.
Flat.
At 180 miles away, the rocket's going to be going up, but it's not going to come up above where you perceive the horizon for a minute or so, and all of a sudden it's going to pop up from there, and then you can see it. It's believing the Earth is easier than understanding how we see it.
It's certainly a very different model, that's for sure.
What is the flat and stationary Earth?
It's a different model from the globe Earth, for sure.
Yeah, the globe Earth is a demonic model. It literally has all 666s in it. It was made up, the Big Bang and the globe Earth was made up by a Jesuit priest. It's incredible. There's so many. 6 times 6 times 600 is the circumference of the Earth. The Earth curves at 0.666 mile per mile. 66.6 thousand miles per hour around the sun. 6 times 6 times 60 is the diameter of the moon. How many of these? There's hundreds. There's 100 of these. Everything is 666. Weird. I know it's just numbers. You could not believe in it, but I'm not a coincidence theorist.
Sure.
And if you do, good.
I was just going to kind of move along and say, so talking about the optics is certainly one aspect of the evidence for a flat Earth.
Sure.
And of course, I can't come to any conclusions. I'll have to go take what you said, go back and have a proper look into it. But so what are some of the other phenomena that are used to argue against a flat model, such as eclipses, such as seeing different stars, northern, southern hemisphere, that sort of thing?
Sure, we can hit those
the
first.
Main ones.
So you're in the UK, you can see the North Star. It never moves. It's in the same spot every night. The Big Dipper points right to it, right?
Polaris. Is it Polaris?
Yeah, Polaris. It hasn't moved your entire life.
Mm-hmm.
Can't see it in the southern hemisphere, right?
Mm.
On the globe, you can't. You can't see it past the equator, but it has been seen as far as 30 degrees south, which is like 1,000 miles of Earth curve you'd have to look through, but it has been seen. Well, here's the reason. And again, eyesight and perspective has been hijacked and called Earth curve. If you and I were in a warehouse, it's got 20-foot high ceilings, whatever, and there's random lights in the ceiling, and we're hanging out. Like, look, that looks like a dinosaur, and that looks like a bull, and that looks like a snake. Yeah, I can see that. And then we expand that warehouse to 10 miles wide, and you say, I'm going to go for a walk, and after half a mile, I can't even see you anymore because the ceiling and the floor have merged together. Right? I can't see you. I could zoom in with a camera, maybe, probably. But that's 5 miles away. I yell, you can't hear me. Right? I call you on your cell phone and say, hey, can you see that snake, that bull, that dinosaur? You're like, no, I see completely different stars. You would see completely different lights on the other end of that warehouse. Does that make the warehouse curved?
No. So is this so we're saying that the stars are stationary lights?
The stationary lights, folk, they never change. They are
So
in the same position, even though we're traveling billions of miles a year, and they're local. Check this out. If you look up at the star Sirius, it's like this big compared to Orion, which will appear
yeah,
a little bit smaller. So I can take my P1000, I can zoom in, and it almost fills the entire lens. I can make the star this big, right?
it's not in focus.
Well, it's a little fuzzy, but I'll show you some ones that are more in focus, and then I can zoom in on Orion. I can make it almost the same size, a little smaller. Okay,
Mhm.
right. So Sirius is 50 trillion miles away. There's so many problems with that. The light, being able to see something, it's stupid. But I can zoom it in 50 trillion miles away. Well, Orion is 52 million times farther than 50 trillion. So 50 trillion times 52 million. So that would mean that Orion would have to be 50, because I can make it the same size by zooming, but have to be 52 million times bigger than Sirius. Otherwise, I wouldn't be able to zoom it in like that.
Well, I'm no astrophysicist, but
You keep saying I'm not a physicist. Thank God you're not a physicist, because you have the ability to think. You physicists literally are indoctrinated fools regurgitating shit in textbooks. David Weiss here. I've been taking Masterpiece for probably over a year, maybe even 2 years, and the detox I feel from it is amazing. I have never felt better in my life. I know that sounds like a lot, but I sleep better. I have amazing dreams when I take it at night. I take it twice a day most of the time, but sometimes I only take it once a day because I forget. But it's definitely an amazing product. And now with the new research they've done where it is literally getting rid of the nanotech in your body, I can't imagine not having any. So there you go. That's my testimony, and I love the stuff, and I'm never going to stop taking it.
Well, I'm no astrophysicist, but
You keep saying I'm not a physicist. Thank God you're not a physicist, because you have the ability to think. You physicists literally are indoctrinated fools regurgitating shit in textbooks. You can learn more by banging a textbook against your head than you can from the information in it.
There's that aspect of it, certainly, but there's also the practical running the maths and having it check out each time and being able to track certain. But anyway, that's kind of speculation, because I'm not one.
If you want to run the maths, you can. This is a stuff.
Yeah, this was my point about that's out of focus. So I've got. So
let
me just briefly.
It looks pretty darn sharp to me.
I'll tell you why I think that. So I've got a telescope. It's a Dobsonian. I don't know exactly the specs, but and this is also addressing the stationary lights in the. Is it firmament? Is that the right term that you use? So I've got a telescope, and I quite enjoy looking through at Jupiter. I can see Jupiter. I can see its moons. I can see the big red dot. I can see Saturn. Now, the thing that interests me is, first of all, if you're not focused incorrectly, it looks like that. Not quite like that, but that's a star, not a planet. But it looks very similar to a lot of what I've seen of out of focus stars. But when you focus in, the interesting thing is you have to keep adjusting the telescope by millimeters at a time, because it moves out of range of what you're seeing.
Yeah.
So something's moving.
So
now, to me, sorry, just to finish off, me that would be the Earth spinning.
So let me.
Of course, it wouldn't be.
Well, hold on. Do you see the sun move across the sky?
Yeah.
Do you see the moon move across the sky?
Yeah.
Do you see the stars move across the sky?
Yeah.
Maybe they're just moving across the sky.
You said they were stationary.
No, we're stationary. The stars and everything in the sky circles Polaris.
Oh, well, you gave the warehouse example, and I said, so they're all stationary lights. You said, yes,
no,
stationary.
So the warehouse lights can be spinning.
Oh, I see. Okay.
But when we're 5 miles apart, we see different stars. They're all spinning around.
So they are moving. Okay.
So let me ask you a question. We're taught that the planets all circle. Where is it? the planets all circle the sun, right? Not to scale.
Mm-hmm.
The planets all circle the sun.
I'd hope not. Yeah.
Okay, that of course is not to scale. So not to scale. All right. So here's the Earth, and
Yep.
our let's just say our angle of axis points up towards a star at the end of that line.
Mm-hmm.
That's Polaris. It's the most important star to us because we're on Earth and it lines up with our axial rotation.
Mm-hmm.
If people lived on these other planets, would Polaris be a special star to them?
No.
No, of course not. All right. If the Earth was angled this way, we'd have a different star and we wouldn't give a crap about Polaris because everything would be, from our point of view, would be circling there. Right.
Sure.
And all these planets would have their own North Star. So that one's there, that one's there, this one's kind of pointing towards the sun. Right. So it would only be important to them. Right. But here's the issue. A second. That all of the planets, asteroids, Juno is an asteroid, all circle Polaris. They all make perfect sacred geometry, spirograph patterns, all circling Polaris when they should be circling the sun. Everything in the sky circles Polaris.
Right. It is in orbits when we say
they all circle Polaris. We're not moving. They're moving. The wandering stars, aka planets, all do their spirographs around Polaris. All the stars make perfect circles around Polaris. If we're moving 4 different directions at once, and if we're moving in 4 directions at once, how would we get perfect time lapses when we look? How would we get that?
Well, I suppose the argument for that, which I'm sure you've heard many times, would be that the universe is ridiculously, stupidly big.
Yeah. So are you familiar with the Georgia Guidestones?
Yeah, I think so. Is that with the hole in it where you can see one of the stars?
Yeah, you can see Polaris.
Mm-hmm. Oh, right? Polaris. Okay.
Yeah. Well, that's the only one that would make sense because Polaris never moves.
True.
Now,
yeah.
We're moving every year. We're 93 million miles away. 6 months later, we're 93 million miles on this side. So that's 186 million miles side to side, back and forth.
Mm-hmm.
The sun is traveling 4.4 billion miles a year. All the planets are chasing it, keeping up with it. They're all ranged on a flat disk around the sun. Weird. All right. Never to return to where we were before, but Polaris stays right in this hole. And so for hundreds and thousands of years, Polaris is still lined up. Now, the argument is, well, in a certain amount of time, Polaris won't be in that hole. And we can go to the Egyptian pyramid, the Giza pyramid, and there's a shaft that lines right up with Polaris. And the argument on the globe side is, well, it used to point towards Thuban, which was our North Star 2,000 years ago, right? But isn't
the argument because the Earth kind of wobbles on its axis as it's turning, so that it alternates? I'm not 100% familiar with it.
Well, that's why we have a new North Star. 2,000 years ago, it wobbled and it was pointing toward another star. But the parallax, there's none. It's like when you're driving down the road, if you try to point at a street light on the side of the road, you'd be going like this. You'd be going, you can't do it. But way in the distance, there's a mountain and there's a big rock on top of the mountain.
It moves like that.
Well, but you can point there and you're not going to move your arm a whole lot very quickly.
No.
Well, they say Polaris is so far away that there's no parallax. Okay, stupid argument, but let's give it to them, right?
Well, it depends on the size, yeah.
The problem is the wobble of the Earth, right? If the Earth wobbles, that's going to move right off of Polaris, right? So the Georgia Guidestones point towards Polaris. Georgia Guidestones were built in 1981, right? You with me? In 1981.
Sorry, I'm just going to fix my camera's thing for you. There we
go. The Georgia Guidestones were built in 1981, over 40 years ago. 1 degree. So they tell us that the Earth wobbles 1 degree every 72 years, 72 or 76, whatever. Right? The 1 degree. So 1 degree in the sky is between 2 and 3 moon widths, full moon widths, side by side. So that's a That's big. 1 degree in the sky.
That's much considerable.
So it'd be over a half a degree, which would be a minimum of 1 full moon width. But we looked through the hole, little tiny hole, and there's Polaris still there. So we went there, we filmed it, we made a video about it, saying this proves that the Earth is not wobbling. If the Earth's not wobbling, the entire heliocentric hypothesis.
I think I know the ending.
What?
They got destroyed, didn't they?
Yeah, right after that. They got destroyed, and a terrorist, and 3 hours later, the bulldozers were there, took the whole thing down, stole the time capsule, never heard about it again, no investigation. You know why? This is what's called rock solid evidence. Rock solid evidence. And they literally took it down, right? This is a little monument we have here in the United States. It's a war memorial. And every day on 11/11 at 11:11 a.m., every year, 11/11, so November 11th at 11:11 a.m., the sun lines up with all of these holes and lights up this little war memorial. Happens every year, never changes. Right? This violates natural law, the 3-body problem with gravity. We can't model 3 bodies, let alone how many bodies we have in our solar system? 100, more with all the moons and everything. Everything works perfectly. Yeah. It's so ridiculous. The heliocentric hypothesis is nonsense. It's just disconnects you from your true common sense. It makes you say stupid things like, I'm not a scientist. I don't know, right? Now, I don't know isn't a stupid thing to say. I don't know is actually a very smart thing to say, but saying that you don't have the ability to figure it out is part of the trick. You do.
I think maybe the way I've been brought up is it's difficult for me to have confidence in a conclusion in something that I haven't been trained to know how to do properly, if you know what I mean. So for me, not understanding, for instance, why why Polaris hasn't moved whatever from the Georgia Guidestones in however long when it should have done. To me, my initial thought there would be, that's interesting. I should ask an astrophysicist about that, or someone who have spent years, knowing exactly how to make these calculations and talk to them, and then try and figure out if that could fit into my understanding, if that would make sense to me.
So you want to ask a guy that his career is based on his memorization and regurgitation, and all of his funding comes from touting the mainstream model. You want to ask him why it doesn't move? Go ahead. He can't answer it. He won't be able to answer it. Let me just show you. This is from the Sun. Where we're talking about the Sun. So this is Stanford Hospital right here. It's a big building, right? See how big it is? No, I'm on my one wheel here. I'm just going down. Now, as we get closer to it, it should get bigger, right? A little bit.
Depends how far away it is.
It's about 5 miles. It's about 5 miles away. So it shouldn't get smaller, right?
So this is the parallax that we were mentioning earlier.
Well, this is how our brain perceives things near the horizon. So the horizon can be this tunnel of trees. And as we get away, look what's happening to the building. This is actually more prevalent when you just view this with your own eyes. The camera doesn't really do it justice. What happened to the building? Wait, keep watching, right? Keep watching. This is how our brain perceives things.
Yeah.
This is why you look what's going on here, right? Because we took that surrounding horizon. You can't even see the building anymore. That makes no sense. All right, look how big it is. Weird, right?
It's interesting when you take away the relative things to compare it to. Right. Obviously, you take into account the difference in slight elevation on the path. Ames window.
Yeah. Oh, so you know about this?
I know Ames window. Yeah.
Yeah. So you've seen that when the pen goes around, right? It's crazy.
It messes with your mind.
It messes with your mind. So I don't even need to show it then. So I'm just saying, when you look up into the sky, you can't determine the shape of the ground, right? How about this one? I'll show you one more. So this one is which table is thinner and which one is longer?
Well, of course, the left looks a lot thinner and a lot shorter, or
longer,
narrower.
It looks thinner and longer, right? So I gave you what's called a false paradigm. Which one is this or that? So I gave you two things. So you're like, okay, one must be one of the. They're the same size. They're exactly the same size. And I'll show you. Here's a piece of paper. That's how big that table is. And that's how big that table is, right? even that I showed you this now, you can't reconcile this in your mind, right?
No.
You can't. They still look different. You can't reconcile it. So looking up at the sky, going, "Oh, that's round." You don't know what you're seeing in the sky, right? Why are the other planets round, right? This is the sun or the moon rising or setting. We'll just say, well, you can't tell if it's rising or setting, but which one is it, the sun or the moon?
It looks too bright to be the moon. It's too dark. So I'd say that's just, I don't know, a light in the distance. But if I were to say,
you're right.
Say
It's not either. But is it? What shape is it?
It looks round.
It looks round, but in reality, it's just a train, and it's not round, and it's not. This is how we see, right? So you were talking about Jupiter before. You'll look up and see Jupiter in the sky. It's the brightest star in the sky, right? It looks like a star. If you didn't know it was Jupiter, you'd be like, "Wow, that's a bright star," right? You can almost say it's as bright as the sun, but it's just tiny, right? But it's bigger than any other star in the sky. It's the brightest light in the sky next to the moon, right? At night. So Jupiter is made of dusty gas, and it's the gas giant. Yeah. So what's more reflective, the moon or Jupiter?
The moon to us.
The moon would be, because it's got a solid surface.
Closer.
Gas absorbs light, right? So the moon, we're about 400 million miles. Jupiter's 400 million miles farther from the sun than we are. We're about 100 million miles, just for round numbers. So the inverse square law on light and size, if we double the distance to the sun, our sun, which is about the size of a coin at arm's length, will be like a quarter the size of a coin. And if we double it again to 4 times as far, it would be tiny. It would be smaller than a pencil eraser held at arm's length, right?
Yeah.
Okay. So if you're on Jupiter, from Jupiter's distance, and you're looking at the sun, it's tiny. It's barely going to light you up. But that light has to bounce off the non-reflective surface, travel 400 or 300 million miles to Earth, and then we see it as bright as the sun. That inverse square law should get a quarter of the brightness every time you double the distance. It should be not visible.
Is that regarding light itself, or is that light through an atmosphere? Because we're talking a vacuum devoid of matter.
Yeah, I get that. But light spreads out as it goes. And as it spreads out, it gets thinner and thinner exponentially through any medium or no medium. I don't even believe light can go through the vacuum of space. I think it needs a medium to go through. So let's talk about the light from alleged stars, right? Do you know why the sun and the moon in your paradigm look like they're the same size? Because the sun's obviously bigger, right?
The sun's bigger and a lot further away. The moon, I think it's just coincidence that they happen to be the same size, is the general consensus of that.
Or maybe they just are the same size. So the sun is, how wide it is?
How wide the sun is?
Yeah.
Bloody massive.
860,000 miles.
Yeah. Pretty big.
So they tell us the sun is 400 times bigger than the moon, and by chance, 400 times farther.
Only 400 times bigger than the moon?
400 widths. So, yeah.
Okay, right. Okay.
So,
400
times bigger and 400 times farther. Coincidence. Therefore, they look like they're the same size. And when we get an eclipse, right, the moon perfectly matches and blocks the sun.
In a solar eclipse, yeah.
In a solar eclipse, right? You know that no one's ever seen the moon approach, eclipse, or exit the face of the sun? No one. I have. No, you haven't. No, you haven't.
Okay. So I haven't seen the full moon as a whole rock come out, but I've seen the
eclipse of the sun.
Yeah.
I've
seen the sun gradually become more and more of an arc.
But no one's ever seen the moon.
The argument there would be that's because the moon's lit from the sun, so we're just seeing no light, so we don't see it.
Yeah. So worse when on a full moon night in the middle of nowhere, the only light is the moon in the sky. You can read a book; it'll cast your shadow on the ground, right? What's that called? That's called moonshine, right? What's more reflective, the Earth or the moon?
Um, well, the Earth, you would have thought,
Yeah, that makes sense,
perhaps.
right?
It would make sense. Well, it's
The
larger.
water, it's larger, right? 6 times bigger. It's
Mm,
larger. It's got water, more reflective. So during a total eclipse, from the moon's point of view, it's got a full Earth. There's a full Earth, right? Like we have a full moon,
yes.
right?
Yeah.
So the Earth shine should light up the moon. Someone should be able to see it. No one's ever seen it, right? Here, do you see the moon?
Um, I would say yes.
No, you don't. You see sky. You see missing sun.
Well, I would say you see, you
You
could argue you see
see
the,
something blocking the sunlight. We can agree on that.
yes, yes,
But you don't see what that thing is. You just see missing sky, missing sun.
sure.
Okay. You can assume that it's something in front of the sun, but I'm telling you, the Earth shine should
Mm,
light it up. They should be able to show it from the ISS, from an infrared telescope, something. We just see missing piece of the sun. We don't ever see the moon, no matter what. We just see missing sky, missing sun, not missing sky. We just see the sky. So interesting. Just keep that in mind. Um, it diverted me from where I was going. Oh, the size of the sun and the size of the moon. So that's just a coincidence. So so size and distance. If something is 10 times bigger and 10 times farther, it appears to be the same size.
mm,
Okay. If the sun 160 million thousand miles across was a mile over your head. We just forget burning up. This is just an example. If it was a mile over your head, so
yeah, it would fill everything.
you're standing on a small marble and there's a yoga ball a millimeter over your head. When you look up, what are you going to see?
Just that. Yeah,
Yeah, you're just going to see the sun. We move it 93 million miles away. Now it's the size of a nickel held at arm's length, right?
sure.
If I double the distance, how much smaller does it get?
Logically, I would say half. But
Well, it's
isn't
half the
there
height,
some
half the width. So it's actually a quarter. But you know what?
right? Yeah,
Let's not
sure,
argue.
sure.
Let's just say half.
Smaller.
So
Yeah,
let's just say half. It's a quarter, but let's just say half.
sure.
So that doubled it, it would be half the size. So it'd be the size of a dime. We'll go with that. Okay. Double it again. So now we're 4 times farther. We doubled the whole thing again. It's now the size of a pencil eraser.
Right.
Double it again, 8 times farther. It's now the size of a large star. It's just a pinpoint
Mm,
of light, right? 8 times farther. They say the sun is 8 light minutes away, rounding off. Takes the light
yeah.
8 minutes to
Take
get
that
to
8
Earth.
minutes to reach us.
Yeah,
Yeah.
so 8 times farther would be a light minute. 8 times 8, 64. Let's just call it a light minute,
Hmm.
right? No, a light hour. Sorry, my bad. 8 minutes,
Yeah. Yeah.
or a light hour. So the light hour away, the sun is the size of, it's smaller than a pencil eraser, but we'll just go with pencil eraser. So let's double it to 2 light hours away. Now it's tiny. 4 light hours away.
Hmm.
It's the size of a star. 8 light hours away. 24 light hours away. If you do the math, the angular resolution limits of our eyes, you could not see it. And ignore the inverse square law of light spreading out at that distance, and we get dimmer and dimmer and dimmer and dimmer, right? There's no argument there. It would, but let's just ignore that. The angular size of the sun would be so small at a light day away, you can't see it. But let's just round it up. We'll go a light week away. Okay. We'll just crazy. Let's just be crazy. At a light week away, you couldn't see it. They tell us Polaris
It's a lot further away than that.
well, they tell us it's 46 times bigger than the sun.
Hmm.
So at a light week away, 46 light weeks away, we shouldn't be able to see Polaris. Let's round it up to a light year, 46. Let's go up to 52. 52 light weeks away is far, 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 far beyond the angular resolution limits of our eyes by magnitudes. We're given the globe everything possible. At a light year away, it would be scientifically impossible to see Polaris. They tell us it's 433 light years away. If you want to get into the inverse square law of light, you have to claim that Polaris, that light doesn't the light will travel, you'll be able to see something that's small because the light's coming, but it would have to be like 100 sextillion times brighter than the sun. Just a number that doesn't even exist, right? Or Polaris is small. It's right here in the sky, in the firmament, fixed in place. All the stars circle around it, just like we witness. The heliocentric hypothesis is absolutely retarded.
So I'm just trying to kind of get the idea of the traveling light through a vacuum, because I'm just trying to think. And I'm no expert, but
you keep
if
saying
light
that.
is traveling,
you keep saying that. Okay.
Well, if light travels through a vacuum, and
careful, you're making the 666 symbol, and people will say that you're an Illuminati.
Is that what that is? I don't know. A very small thing, a proton. A proton travels through void. Light travels through void.
Yeah.
Why would it?
Does it travel through a void?
We're taking it. Take it for granted. This is what's happening. Traveling through a void. Why is that brightness diminishing when there's nothing for it to be interfered to interfere with it?
Spreads out. Like if you hold a flashlight against a wall, it makes a very focal point. And as you pull that flashlight away, it spreads out, and it has to spread that light over a bigger and bigger area. Even a laser beam spreads out and gets weaker and weaker. So I had a point that I wanted to make that we veered off of. What the hell was it? I don't remember.
I do a lot of interviews, and it always happens to me. Don't worry.
It's all right. Yeah. Are you breathing air right now?
I hope so.
You hope so? I hope so too.
Because if not, I'm already dead and I don't know it.
Yeah. So do you know that air needs a container? Otherwise, it'll equally fill the available space.
Well, on a smaller scale, yeah.
Okay. So here's a gas pressure simulator, and we got air going in all directions, biased. It goes in all directions. It's not going down. And if I open the top, without even being a lower pressure out here, it will just will start.
It'll fill it.
Yeah, but if I had if I could lower the pressure out here violently, it would go out. Now they tell us that we have the gravity holds the air down, which it doesn't, and that we have a gradient as we go higher and higher. The air gets thinner and thinner, which is true, but the air pressure gets less. But the thing is, you can't have pressure without a container, right? If I said, "Hey, come over for a barbecue, bring me 5 pounds of propane, but don't bring it in a container." I hate containers. Could you do it?
No,
it needs a container. But if you had a half a tank of propane, it's liquid on the bottom, thicker in the middle, less thin, thinner, and thinner at the top. If I put a hole anywhere in there, it would immediately evacuate and equalize with the air pressure around.
Sure.
Right.
But the argument there would be that a gas container, or even a truck or a football stadium isn't the Earth, which is very, very big and has its gravitational forces acting on it.
Okay.
And so you can't apply kind of everyday mechanics of pressure, etc., to something so huge.
That's cool. But now I'm going to completely dispel that. So here we have some gas in here. We have a vacuum here and a valve separating the two. And as soon as we open the valve, the air will violently and quickly equalize. Yep. Open, and it instantly equalizes up and away from gravity. Okay?
Yep.
Now let's pretend that this vacuum is infinitely large. What happens when we open the valve? It's still a vacuum. Instantly equalized.
So the which is infinitely large, the empty valve.
The vacuum. It's just we're going to make it 1 trillion times bigger of an empty ball. It's instantly going to
and the NO2 stays the same.
Yeah, or bigger, doesn't matter.
Yeah, it would.
It's gonna.
If it was big enough, it would have its own gravitational force, and therefore it would.
That's what
again create a gradient.
Yeah, so I'm going to prove to you that gravity doesn't do that. So this is the pale blue dot photo. Remember that?
Depressing, isn't it?
From the Voyager, right?
Yeah.
So here's the Earth. It's got gas around it, and here's the infinite vacuum. The air would be gone in a second. Not even a second. it would be gone instantly. But for some reason, that little Earth is holding on to all of the air, and the Tor 17 vacuum. This isn't even the other one wasn't even a Tor 17 vacuum, right? You can't have air pressure without containment. Now, I know where you're going. In your paradigm, they say that the gravity is stronger on the ground, and you go up, it's slightly less, just a tiny bit, but it doesn't get more. The higher you go, it just becomes less.
Yeah.
Right.
Well, the force of gravity gets stronger the closer you get to the center of the mass.
Okay. So that's what they tell us. That's what they tell us. And I'm going to disprove that right now. So I want you to envision a vacuum chamber, a big vacuum chamber. And in that vacuum chamber, we have a fish tank, just an empty fish tank, right? And the walls go and the fish tank go all the way up to an inch before the ceiling of the container. So it's got an empty tank. And we have a hose going into the vacuum chamber on the floor, and we slowly start lowering the pressure. We just start lowering the pressure. We're lowering the pressure, and we're lowering the pressure. At no point does the air pressure inside the fish tank be greater than the air pressure out.
It's constantly equalizing.
Yeah. So why doesn't gravity, which is stronger because we're on the Earth, why doesn't gravity hold a little bit of that air in there?
Well, because the container isn't the size of the Earth, so it doesn't have its own gravitational.
No, we have the gravity of the Earth.
Oh, I see what you mean.
Gravity, right?
Right. So why does the Earth's gravity not hold this down?
Yeah.
Right. Hang on. Let me figure out again. So you've got is the vacuum tank sealed?
Of course, vacuum tank has to be sealed because you can't have a vacuum without it being sealed.
Exactly. That's my
point.
You
can't have air, high pressure air, without it being.
Yeah. No, this is kind of beyond me. I don't know.
It's not beyond you. You just haven't been taught to actually think and use your God-given common senses. You don't need to be taught this by anybody. You can figure it out yourself. We are incredible brains we have, and the ability to look at information and apply it to reality. You are believing in a cartoon world that you've been indoctrinated to. It's easier, as I said earlier, it's easier to fool somebody than to convince them they've been fooled. You've been fooled before you can talk. Your parents probably put a mobile of planets above your crib and gave you NASA pajamas to wear. Okay. Mine did. Okay. I did to my kids. Right. So it's nonsense. Why are they teaching kids before they know anything real about the orbit of the moon and the sun? And why are astronauts on Sesame Street? Why is everything globe related? Because when you're on a globe, you literally lose your ability to think effectively, right? We are incredible spiritual beings. We have the ability to connect. So if you look into the old world, yet, probably not.
The old world,
yeah. So you think flat Earth is a rabbit hole? You just wait, okay? And we have these incredible brains. They tell us that we don't use 10% of our brain. You want to use 10% of your brain, you globers, right? We use all of our brain, and what they do is, your thoughts create your reality. If you are contained inside a globe, this is all you can think about. You can't think beyond the box that you've been put in. Your thoughts create your reality. Look at your life. Everything you've done is because of the way that you think, right? When they said, I want to play guitar, and you knew that you're going to, and now you play guitar. I assume you play guitar, right?
Yeah, I do.
Guitar. Yeah. I see a guitar.
I also like foxes.
Okay.
And I'm writing a book about foxes.
Yeah, well, and because you imagine that book and you saw yourself and you're in the flow state, and now you're going to do it and you're going to create it. Your thoughts create your reality. And if you understood, it's not just the law of attraction. If you understood how, I'm going to use the word magical because I don't know a better word right now. This world is conspiring to give you everything that you think. And if you understood how the moon cycles work and how to manifest using the moon cycles, you would understand that this world is nothing like they tell us. Nothing like they tell us.
So in that case, what is the moon, and how does it affect our consciousness, I suppose? If the moon's not a physical thing, there's a light on the firmament.
I think the moon and the sun are literally just sound waves, but that's a whole nother deeper topic. The moon syncs up with women's menstrual cycles. So my personal opinion is, and there's ancient teachings that the moon is responsible for delivering and removing souls on Earth. Speaking for myself, that's my belief. I don't have any proof of it, but it is not a rock floating in space that women somehow sync up to. It's not a rock in space that's pulling the water away from the water, away from the Earth, creating high tides, and pulling the Earth away from the water on the other side of the Earth, creating another high tide. It's all nonsense. When you actually start looking at the heliocentric hypothesis, you realize once you see it, Darren, you're going to be like, how did I ever believe this nonsense in the first place? How did I ever believe it?
Oh, interestingly, the reason I got in touch with you was for a recommendation from Andre, who I had recently. He's a prolific out of body experiencer, and an experience that I'm looking to try and induce myself through various different means, which I believe by, as
Andre,
you rightly say, as you should, I believe by experience. He did, yeah.
So I know. Do I know Andre? I mean, I did with Darius J. Wright. You know,
he's one of his. I do. I reached out to Darius, but didn't hear back from him. He'd be an interesting one to talk to. But Andre is one of Darius's students. He goes by the handle.
All right, I think I know
the Alchemist. Yeah.
Okay.
So he recommended you to me because he came out of his body and saw the flat Earth. Now, to me, and I'm not yet convinced of a flat Earth. I couldn't be.
I don't want you to be convinced. I want you to go figure it out yourself. I want you to go.
Yeah.
Here's the thing. If flat Earth was such nonsense, they wouldn't censor it like they do. They don't censor fairies and Loch Ness Monster and all sorts of other things, aliens from outer space, which is ridiculous. I mean, it violates natural law. We are contained, right? It is provable that the air must be contained. And if there's a container, like a terrarium is a container, then there has to be a creator. They're hiding God. They don't want people in a position where they can't deny the existence of God.
And that would be the concept of God and everything would be a whole other discussion. Maybe we could have if you'd be interested, because that's a whole big subject, what God is and what that means. But
that's where I draw the line. I let people figure out what God is. I just show you that there's no option for no God, right? And then the rest is your own journey, right? The rest is your own journey to figure it out what God is to you and your relationship, right? Mm-hmm. So I was kept away from God my whole life because of Christians that are like, you're going to hell if you don't do this, right? And I was like, you are friggin' crazy. And I wouldn't even look at it. I was in a trip to Bermuda as a young teenager, and it was a Young Life Christian trip. And they're like, hey, they brought us to this cliff, and they're like, all right, everyone sit down, and we're going to do a Bible study. And now I was born Jewish, non-practicing. And I'm like, oh, Bible study. This is interesting. I've never even looked at the Bible. And the first passage he read was, I forget the name of the passage, but the stars fell to the earth. I'm like, star can't fall to the earth. The star would eat the earth, right? And I discarded the Bible for 45 years after that. But I didn't become a flat earther because of the Bible. Discovering the flat earth made me understand that there is no other choice than there is a creator. And it happens to be that the Bible is like a super accurate book of our history, our future, science. It's incredible. But that's not the reason I'm a flat earther. Science, actual science, makes me a flat earther. We can test why things go up and down, manipulate it, do a scientific experiment that proves that electrostatics is the reason. And gravity is just a stupid theory that's 96% wrong. Neil deGrasse Tyson himself says we are 96% stupid about our solar system.
Well, I mean, I've always said reality is so extremely complex. We haven't even begun to start. I mean, people try to, say that the brain creates consciousness and take that as an assumption. There's no evidence for that really outside of correlation.
I think the sun is responsible for our consciousness. The sun is a living entity. If you check out Crow 777 Radio, I highly recommend everybody. It's 2 hours in Crow, CRROW 777 Radio. That you subscribe to him, but he has a hydrogen alpha telescope and has been filming the sun like no one has ever had before. You look at it, this is a living entity, right? If you understood what water is a living entity, right? When people pray over their food, they're literally changing the water in their food, which changes who they are. Right? When you understand the power of intention, the power of thought, you're not going to let these stupid heliocentric controllers control your mind. They keep you in a state of false evidence appearing real, FEAR. Fear is how they can control you. right? And then ego, they build your ego up. Well, I'm not going to be fooled my whole life. I know the earth is a globe. I love Star Trek and Star Wars, right? It's all nonsense to keep you living in fear. Before I forget, if you Google flat earth, you're going to get fed nonsense. All of the information, bypassing all of the algorithms. This is my app, the Flat Earth Sun, Moon, and Zodiac Clock app. And this is the challenge I give people. A couple different challenges. You can click right here. Every day there's a new video. While you're having your tea or coffee in the morning, just watch the daily video for 2 weeks. At the end of that 2 weeks, you will be a flat earther. Or you can go to the crash course. It's on there. It's also on my website. You don't even have to get the app. Go to the crash course banner, turn off Netflix, and watch the first 3 or 5 videos. You will be a flat earther, right? You will never find this information on your own. They don't want you to have it, but this bypasses it. If you have a question about flat earth, you hit the question mark button and all of your questions are answered here. Why would they lie? Why would they lie? Great videos there. Where does the sun go? Circumnavigation, how does that work? Circumnavigation proves flat earth. Seasons prove flat earth, right? What about the tides? Amazing. International Space Station, if you want to laugh. Maps. Oops. Just hit one of the buttons. There we go. What about tsunamis? What about time zones? Right? All of them are answered here. And then for you, also, over here, the button that looks like a dragon, it's really a griffin. That'll take you to the old world section. Everything, without exception, that you've learned about our history is a lie. We are not at the pinnacle of civilization right now. We are literally in the final credits of the movie Idiocracy. There was an advanced civilization here just a couple hundred years ago, worldwide, far more advanced than we are. All the videos in here will teach you about that. My lunch break. Just go to YouTube, search my lunch break, start watching those videos. And then you'll understand that what's going on. You'll understand what's not going on. And that what's not going on is that you're an insignificant speck, that you evolved from a lightning strike that struck some primordial goo, created an amoeba. That amoeba turned into a fish. The fish grew legs, climbed out of the water, found another sexy fish with legs, and had a monkey. And that monkey had a retarded baby that became a human. That's what you have to believe.
That's another interesting one, because I do strongly think that evolution happened, however, to get to us. However, I also think it's most likely that there was an intelligence at the core of that process. I don't think it happened statistically by chance. I haven't looked into that. I might be totally wrong, but that's where I am at the moment.
Well, you're kind of halfway there, but if you just look at the human eyeball, like right now, I'm looking at you on the screen here. I got lights, I got trees in the distance. I can see the sky beyond that. I can tell what's going on. All this stuff is going on while I'm talking to you. I'm taking in all of this data. That's not a random chance. That is design, right? If you're walking in the middle of the woods and you come across a 100-story skyscraper, was that by evolution, or is there a creator? Is there a builder? Right? This place was built for us. It was designed for us to thrive. There was free energy everywhere, right? We were in, God didn't just build the earth and throw 2 cavemen down there and go, good luck, right? He literally built infrastructure, which is beyond anything that we can imagine. You need to learn about this stuff. The Old World section will teach you about that. You look into biogeology. Geology is just hardened biology. Wait until you start going down that rabbit hole. Here's the beautiful thing about flat earth. You'll never be bored again. You'll be exhausted. You won't be sleeping much, but you'll never be bored again for a second. The word boredom does not exist in my life. And it's absolutely amazing. So get my app. That supports me, but it really supports you because it's only $3, one-time charge. There is some advanced features which I've added, which require an $11 a year subscription. If you want to communicate with other people, but you're in the UK, right?
Yeah, I am. Yeah.
So I'll just show you on the UK. Here is the UK, right here. These are the people that have my app right now in the UK.
Very widespread. Congratulations.
Here's what I want. I don't want to be able to see the countries anymore. They have to all be, completely covered. And we're almost there. Look at these. I mean, nobody lives here in America. There's not many people out here. So that's why it's not there. It's It's not, and people are like, oh, you're a grifter, you're doing this for the money. I walked away from my own business where I was making large amount of money, and I walked away from it all to be able to help people find the truth through the censorship. Because if we don't take our world back, we are absolutely screwed, and there'll be no future for us or for our kids. Um, as I said, the ball keeps you in their paradigm. If you he who built it owns it, and so if you play on their ball field, you literally have to play by their ball field rules, right? And people say, "Well, what has Flat Earth done for you? What has Flat Earth done for you?" And I say, "Well, it 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 I'm at more at peace. I'm no longer in fear at all. I literally love every single day. I no matter what happens, I'm like, this is absolutely amazing. Greater sense of freedom. I think there's way more land out there that they're not telling us about, and a closer connection to the creator, which I did not have. So those three things alone will do it for you. They're hiding. Here it is. Divine law is the law of God. Common law is the law of the land. Statute law or admiral maritime law is the law of the sea or man's law. So in order to convince a man to give up his divine rights and their common rights, you have to convince them that they're not divinely created in a divine world. If the government admitted that we live in a flat earth, God created it, they could not make any laws, right, which are not natural law. They're just more policies that they couldn't do it. So they created their own world, and they got you to buy into it. They got your parents to, turn you into a stock certificate and hide the the truth of our world. And people say, well, why the lie? I still have to go to work on Monday. Well, they're hiding free energy. How would you like not to have to pay for gas or electricity? How would you like to not have to pay, for food? They're hiding your spirituality. They're hiding the creator. More resources, scientific knowledge, what's in Antarctica. They're hiding the fact that we're special. We're at the center of creation. They don't want you knowing any of that. And that's why this is the most censored topic out there. But we are in the apocalypse, which is the unveiling of the truth. And anybody that wants to learn can learn. Again, I can bring you to knowledge, but I can't make you think, right? I can't explain it. I can explain it to you, but I can't explain it for you. You need to take the time and do the work. It's a lot easier to believe because when you believe something, you can just go take a nap, right? You can just go away.
And I would encourage anybody. I doubt there's any on your side, but any that are still watching on my channel who are immediately saying, "Oh, flat earther, ignore it, it's nonsense." I would say, fine. Most people would believe that, but don't dismiss anything ever without at least taking the time to consider and look a little bit into it.
I'll pay you for your time. 3 Bitcoins for 1 globe proof.
And as a cryptocurrency guy myself, I know that's quite a lot.
Yeah, there you go.
So I appreciate you coming on, Dave, and thanks all of Dave's viewers for having me on. I am not a flat earther. I'm still 95% globe, which is where I was.
No, before we go,
but just to finish off, you've given me, a lot of very good points to think about, and I certainly will go away and have a look at them and try and kind of rectify them into my belief and see where we go from there.
Check out the FAQ page. Also on the app, if you hit the web button, which is the more resources page, there's flat Earth proofs. We've done all of the experiments for you. We've documented them, and you can go recreate them. But check them out. We've completely nullified the ball. Right? There's a book section. There's all sorts of stuff. I'm going to be speaking at 3 conferences. Anybody near Arizona or Texas or Mexico, I'll be speaking at 3 conferences. You can find it on my website, and they're great places to meet like-minded people. Everything can be found. All you have to remember is my name, flatearthdave.com. Everything can be found there. The conferences, the app, the crash course, free. Just go watch the crash course, right? And I say if you got through 5 videos, you're a flat earther. So don't do it if you're not ready to give up your globe and you just want to hold on to your ball, because a lot of people don't want to give up their ball, right?
Indeed, but
Don't take my
equally,
ball away, please.
look at the counter arguments in favor of a globe, and then come to your own conclusions to what you think is the most reasonable for your belief system, and whatever
Before,
makes you happiest, whichever way that goes. You say, Dave, as a flat earther, as you say, you're probably the happiest you've ever been in your life. So all power to you. Even though I don't agree with the shape of the Earth yet,
all
I
right.
can't say for the future. Then all power to you for
Before we go,
living your best life.
just like you said, you're going to be looking into it. I would like to look into what your number one globe evidence is that holds you to the globe. Just let me know so I can look into it.
Interesting. I've never really properly thought about it, to be honest with you. I just kind of take it for granted, I suppose.
Yeah. Well, I have evidence that we're
well,
not on a globe, and I've actually thought about it, and we've done experiments, and we have measured it. We've used science, and we've done all of that. But you are in a religion of belief without any proof. What would be your number one reason?
I get your point.
Yeah. What would be your number one? Think about it for a second. If you believe that you live on a globe, I don't believe the Earth is flat. I know it's flat, right? You believe
powerful
on a
statement.
globe. What would be your number one?
Well, I know your reply, but I will say the photographs that we've taken of it and the various people that have been allegedly up into space, including like YouTubers and whatever, it's standard people who have been up in a ship and have seen the curvature, plus pilots who have, I think the limit I actually saw a peer-reviewed article about this recently, actually in preparation for this. 35,000 feet is the minimum where you can start to see a curvature, and pilots above that and even below that sometimes have reported seeing the curve. So I'd say those two are kind of the strongest reason that I would have.
Actually, at 127,000 feet, there's no curve, and there's plenty to show you there. But I know we're just wrapping this up, but this is the 2012 NASA photo of Earth. So here's America, Mexico, Florida.
America is very big.
Yeah, this is from NASA, right? So let's compare this to a world map, right? So we get the map, we get the world map, and I put the globe right here, matching up perfectly. So you now have to believe that all of this land is on the other side.
Again, I would.
Wait, again, what? Let me hear your excuse for this, because this is.
I was just going to say. Again, I'm not a photographer or anything, but I would say that is, as you were saying earlier, more of an optical illusion based on the angle or whatever. I don't know, but that is one plausible way, perhaps.
So
again, I'm speculating completely.
Again, all of this, you're scrambling. It's what it's called. You take all of this has to be on the other side. So check this out. NASA was nice enough to give us another shot. So here's just a different map. I got the same thing here. So all of this has to be on the other side. But if we go to the other side, NASA again, here's Africa, and we'll put it here. Now all of this has to be on the other side. So if you can't deduce from that these are paintings, these are fake, these are not real, I can't help you.
Sure. Well, there'd be no way for me to prove that.
Well, there's a way. You can prove that this is not Earth because I'm showing you this. The only explanation for this is that these are paintings. There is no other. There's no other evidence that you need to compare at all, right? There's nothing. There's nothing at all.
It'd be interesting to plug that image into an AI and see what that would say. Just it's gonna curiosity.
That is interesting. Let's see. I'd be curious to see what they say. But we catch AI lying to us all the time. Here are 9 images of Earth. 8 of them have to be fake if all 9 aren't fake. It's absolute insanity. And by the way, here's another picture from NASA. 2012, 2013. United States got way smaller. Well, what is going on? These are stupid paintings, and this is what's holding you to Earth, right?
I guess unless you invoke strange camera trickery or zoom differences or whatever.
So we can drive across Mexico and Baja here, and we can actually verify that that's 934 miles from here to here. We can actually measure that because we can touch it. We're not looking at the sky. We're not looking at optics.
Sure.
So we could say this red line is 934 miles. Well, they tell us the diameter of the Earth is 7,917. So I should be able to fit 8.5 of these in between these 2 lines. I can't do it. Again, another proof that the thing that's holding you to the globe is cartoons. You're clinging on to proven cartoons to hold you that's holding you there. You're clinging on to cartoons.
I mean, it's interesting, but I wouldn't be able to conclude that it's not real until I know the full kind of context behind how that picture was taken, et cetera, et cetera.
It was
that just
taken
wouldn't be
with
fair to
NASA
conclude.
from like a million miles away at a Lagrange point, which is absolutely ridiculous. Darren, you've got some work to do. I can't make you understand. I can show you stuff. If you're still holding on to photos, you need to really look into it. You really, really, really need to look into it because I just proved to you that those photos, and now, by the way, NASA admits they don't have any photos of Earth. They say they're all images. They won't use the word photos, right?
You're talking about things like composites and things like that.
Yeah, they have no photos, but they got photos of Jupiter and Pluto, right? But none of Earth. Here's two pictures from NASA, 1978 and 2017. They're like, look, we're polluting the Earth. We're losing. This is literally what they showed us. They said that we're polluting the Earth.
Same clouds.
Same clouds. Same clouds. Right? So when you say, I believe the Earth is a globe because of pictures, is the source of your information credible? The source, that would be NASA. Are they credible? Because I can completely destroy NASA. Check out
I mean, it's NASA and all the other space agencies.
They all do training in Florida at the NASA facility. All the other franchises of NASA. It's literally a world deception franchise run by governments. It's complete nonsense. Absolute and complete nonsense. And once you start looking and actually examining, then you'll know. Then you'll know. But you have a belief in cartoons right now that you don't even understand. Right?
That's fair. Yeah.
Yeah. Here's 127,000 feet flat, local sun, local light, flat. Right? And you think you can see curvature from an airplane?
Well, this is just reports from pilots and things that I've seen.
Well, here's the other thing. When you look forward, you see a certain distance to the horizon. When you look at 1 o'clock, 2 o'clock, 3 o'clock, you see the same distance to the horizon. So on a ball, you see the horizon here. If I'm standing here, I'll see it here. That's a curved line, but it's level. On a ball, it's level because you see the same distance in all directions. So that horizon isn't curving like that. It's curving around you, like putting your head in the middle of a hula hoop. And you see that curved line and say, oh, the hula hoop's a sphere. No, it's just the limit of our vision in all directions. And it would be exactly the same on a flat Earth. You would see the same distance in all directions, just like a globe. However, on a globe, it should drop. It should drop, but it doesn't drop. Right. And just to give you the last thing, I know that we're well over.
Oh, just before we go, that image is stuck in my mind. I'm just very curious to see what an AI would say about it. Is it freely available on Google Images?
Just go to Blue Marble, whatever.
Blue Marble.
It'll tell you that's a picture from NASA. It's going to tell you all sorts of stuff. But I have a whole series of me cornering AI and the AI admitting that the flat Earth model makes sense and the globe model is impossible. We've done it with satellites. We've done it with the communication, the Starlink. AI admits it would work way better if all the equipment were on airplanes.
Interesting.
Yeah. So my YouTube channel is DITRH, but you don't need to remember that. It stands for Deep Inside the Rabbit Hole. Just go to flatearthdave.com, and then all our social medias are there. Go to my DITRH and subscribe and check out the AI videos. They're hysterical. Darren, I would love to do this for you all day, but I don't want to melt your brain, and I do have to go.
Sure. No, I appreciate it. Yeah, as I say, not a flat earther yet, but you've given me a lot to think about, and I'll definitely have a look into it.
Okay. Don't let cartoons tell you what this world is. Use your eyes, use your God-given common sense.
Sure.
All right.
Okay. Well, I appreciate it, Dave. Nice to talk to you.
Hey, everyone. If you enjoyed this interview, please help support my work and help wake up others by referring or gifting the app to at least one person today. By doing that, you're going to help wake people up and help me to continue doing other interviews like this. With the censorship out there that's going on, it's very difficult to find relevant information. And the app, as you know, brings people to the truthful information of our world. So help support my work, help support your efforts in waking up friends, family, and strangers. Gift them the app or just recommend the app. And let's make 2025 the year Flat Earth breaks free. Check the links below for information on how to gift the app or just refer the app to others and use your referral code to earn Dome cryptocurrency and a free subscription. Thanks.